Class rep.
Oh, so I was saying, can you record the session?
Okay, thank you. Christopher, do you know how to write from your side?
No, there's no option.
It is there. It's fine. I will teach you for future. But now, I will want the members to give you the following information. You will confirm it. They must give you this information. I will request that the information from you, degrees of freedom of the three. The other part, you'll find it, the MS part. And the last one that I need is what? Is the F value. Can you please communicate with the members? Please, guys, respect leadership, Christopher. Can you please give him the correct values here for this, and also the F value? And then I'll ask him to give me that information. Christopher, you can ask them any question that you want to ask them, and then I'll be doing the writing. Communicate with them, Christopher, and then you give me the information. Christopher, unmute your mic. Christopher, I said communicate
Yes,
with
sir.
them. Yeah, communicate with, tell them what you want from them. They will give you the answer.
Yeah, I already have SS. Somebody's already gave me SSR. Let me see.
Yeah, your voice is not that clear, Christopher.
Am I clear now?
Yes, now it's better.
Okay. The value of SSR is correct. 2261.42.
Okay. You're saying is what, Christopher?
2261.
2261.
0.42.
0.42.
Yeah.
Yes.
SST. Can somebody give me SST, guys?
Is it correct, Christopher?
Yeah.
Comparing what with what you have?
It's correct. 2373.
2373. And the other one is saying 1158.
No, it's not
So
11. 111.
I wrote 3.
Yeah.
I wrote 111, yes. Let's go.
Yes. And the degrees of freedom, let's see. The degrees of freedom, it's 17 for SSE. Yes, it's correct.
Okay. I wrote that, Christopher.
Yes. And then for SSR, it's 2.
The other one is 19. Can you please
Yeah.
give me the F value? You know how to do the middle part, isn't it? The MSE. Or can you please give me the value of the MSE?
The MSE, okay, let's see. I'm still waiting.
Help Christopher, guys.
Yeah, there is MSE. It's 1130, comma 7.
How do you get 1 when you divide 111 by 58? How can you get that big number? Can you please confirm the value, Chris? MSE.
No, it's MSR, that one. MSR. Hello, sir.
Hey guys, what about F? What is your F value?
Sir,
Yes.
F value it's 172.
172,
271.
27. I indicated that when we're busy with the first two chapters, there was a part where you said t squared is equal to the F value. That statement is only applicable when we are dealing with simple linear regression, please. When you are having only one independent variable. But now you cannot say t squared is equal to F. It's only applicable when you are dealing with simple linear regression or when you are having only one independent variable. I know Mr. Chabala clarified that one. I'm just reminding you that please don't confuse the two. So now we have our ANOVA table. What are we supposed to do with this ANOVA table? We have to do the hypothesis testing. You know the steps involved in hypothesis testing. I don't want us to waste a lot of time explaining that this is the first step, this is the second step, and so forth. You know the steps of hypothesis. You know that the first one is supposed to be what and so forth. We are going to follow the very same procedure from the knowledge you got from Mr. Chabalala. Um, so let's go now. We have the F calculated. Um, and again, Mr. Chabala told me that you have different methods of testing. There's a part where he was telling me about comparing the MSE with the MSR and so forth. But the one that I want us to use here, we're going to test using the F value, the one that we calculated there. So let's go, guys. Your null hypothesis. What would be a null hypothesis? We discussed this yesterday. I'm not going to write it here, but I explained yesterday how I want you to write the statement. Yes, Christopher? The null hypothesis?
The null hypothesis, it says there is no linear relationship between the x independent variables and the y.
And the y. That's true. So are we fine, guys, with what Christopher said about the null hypothesis? Did you get what Christopher said? Candy, can you please repeat the statement? So I noticed that you are saying you are fine with what leadership Christopher said.
He said there's no linear relationship between the dependent variable and the independent variable.
Which is in this case we can be specific, Matsibe. We can be specific. How many independent variables are you talking about? We know how many independent variables we have, isn't it? We know we have two. So please be specific that two with these two independent variables. Okay.
Okay.
And the two independent variables. Be specific. So now we're fine with that one. Let's go to H1. If you recall yesterday, we debated a lot about this statement. What would be an alternative hypothesis? What would be an alternative hypothesis? Candy, do you want to try this one? Candy?
We said there's a linear relationship between y and the two, and at least one of the independent variables.
Thank you very much. Can someone try this alternative hypothesis like what Candy did? Candy, you are right, but I need a different person to say the very same or similar statement. Can someone give me the alternative hypothesis? Danisile? Danisile?
Sir,
Yes, Danisile?
before I try, is it okay for us to generalize? Before I try, is it okay for us to generalize, or we have to be specific on which one is the independent variable and which one is the independent variable? Like in this case.
Not really, but it would be good for you to be specific. If your dependent variable is price, it would be nice to say price, because whenever you conclude, you must conclude based on the given problem. So I think it's a good point, Damini. Please be specific. But I'm not saying I'll mark you wrong if you, instead of saying price, you say dependent variable. But it would be good if you do what you make sure that you relate whatever statement you write with the given problem. So you can come in, Danisile, be the first one to be specific.
There is a linear relationship between
You're breaking, Danisile.
my network was
down. The network. Yes. Yes, try it.
There is a linear relationship between price and at least one of the independent variables, size and age.
Thank you very much. Thank you very much. The way you said it is so perfect and correct. Now, as I've indicated, I won't explain some of these things because we'll be wasting time. Because Mr. Chabala told you these things. F calculated, no, tabulated, yeah, you can say F calculated. We agree that is 172. I think it's 0.72. And then F tabulated. You know the correct way of writing these steps. F tabulated will need F of what is this is 2 is what? Is the degrees of freedom of regression. And 17 is the degrees of freedom of what? Of the errors. So you go to the F table. I am specific here that can you please go to that table, or the 5% table, and look for 2 and 17. Mr. Home gave us the value. We just want to confirm what it, oh, it's 2, sorry, this one they're saying is 228, 2628, 28 or 26. It's just a matter of rounding off. So Mr. Homo gave us the value. He said it's 3,5. Can someone confirm the value from Mr. Homo? He said it's 3,592. Can someone confirm this value?
Yeah, it's correct.
Please check the comments there. Your coordinator wrote something. It seems like there's someone who's not having the group, so she wanted help there. So Mr. Chamala responded to your problem. So you have the calculated, you have the tabulated. Can you please give me the decision? Decision. What you wrote, Mr. Omune, it's like oh, decision. My decision is wrong. Maybe that's why you also wrote a statement that is incomplete. Yes, Mr. Omu.
We reject H null at 5% level of significance.
Is it H null? Well, why are you saying it's H null?
H zero.
I will reject the null hypothesis at Y because it's very, very important. You cannot just say you reject. You reject it because based on what?
The F cal is greater than the F tabulated.
Thank you very much. Because the F calculated is greater than F tabulated. So, can someone conclude now? Whatever Mr. Holmes said is we're just deciding. Can I get the conclusion now? Can someone conclude? Please, I don't need Mr. Homu or yes, Manga. Manga. Can I get another person, please? Manga.
Yeah, sir, there is a linear, sir, can I conclude? There
Yes.
is a linear relationship between the dependent and at least one of the independent variable at 5% level of significance.
Okay. Yeah, but you can just modify a statement, but most of the things that we need, you manage to capture them there. That's a matter of modifying what you just said. But most of the things, key ways that are there, the key things are there, it's fine. So you reject. But the question that remains now, you have rejected and say no. Some of the, at least one of the independent variable is very, very important to predict what? To predict why. So now we're in this situation. What do you mean by at least? We are saying at least. Let me delete this. When you say at least, let's understand this at least part. The at least part. The at least part, at least one. We have y. It's possible that there is a relationship between y and x1. There's a relationship between y and the two independent variables. And there's another possibility that based on what we have concluded from the ANOVA table, these statements are possible. It's possible that the relationship only exists between y and x1. The third one, it's possible that there can be a relationship between y and only x2. So now, the ANOVA table cannot tell us which one is correct between these three possible options. So now, when we move to the t-test, we want to check which one from the three is correct. Why? The first one I said, why? The first statement that I wrote there, it means there's a possibility that there's a relationship between y and the two independent variables. The second one, it says, no, the relationship only exists between y and x1. The other option that is possible is that the only relationship that exists is between y and x2. So now we'll move to the what? we'll move to the t-test. We'll move to the t-test to get the answers based on answers of what is happening here. But from the ANOVA table, you cannot tell. But what are we suspecting? What did we see from the scatter plot? Anyone who can recall what happened from the scatter plot? What did we say about the scatter plot? Yes, Omu?
We saw a linear relationship between the independent and the dependent variable, which was
Are you still there, Omu?
yes.
This one I said is size, and then x2 is age. Malep is saying there is a linear relationship between price and size. That's what you saw from the what? From the scatter plot. What about y and x2? That one, it was positive, isn't it? Leadership, Malep. It was a positive one, isn't it? Yes, a positive linear relationship, but you cannot tell the strength. But you notice that that relationship is a positive one, but the strength, you know, you cannot tell from that point. So recall what you saw from the scatter plot. So now, as I was saying, we expect one of these three statements to be correct. So if we concluded that there is no relationship between, if we concluded that there is no linear relationship between y and those two independent variables, which option is correct from the listed ones here? If we concluded that there is no linear relationship between y and the two independent variables, which statement is correct from the listed ones? You can answer my question via the chat.
None, sir.
In the form of hands, please. It's good when you raise up your hand so that we can move. Yes, leadership, Christopher.
There's no correct one.
There's no correct one. The reason, so your model will, your final model will be an intercept model, isn't it? You will only have a model with what? With only beta 0. If that is why now, so my question that will follow is that if you fail to reject the null hypothesis, is it necessary to perform the t-test? Mr. Omu, can you elaborate? Yes, it's fine. Manga, come, you can answer the question.
No, sir.
No reason being?
Because we have concluded that there is no linear relationship between the dependent and the two independent variables.
Thank you very much. So there's no way that, because there you are trying to check which one is related, but now if you've concluded that none of them are related to y, so there's no need to move to the t-test. So you must know when to move to the t-test. It's not always the case that you have to do the t-test. Thank you very much for that. Refilo, I assume you know the reason why you said no. Refilo? So,
Yes, sir.
again, if you can check, I said the meaning of at least one is based on these three possible answers. Imagine if you said your alternative hypothesis is that there is a linear relationship between y and the two independent variables. Suppose that's what you said. It means you are 100% sure that there is a relationship between y and the two independent variables. Your statement is only covering this one. Your statement is only covering the first option. If you say there is a linear relationship between y and the two independent variables, so there's no need for you to do the t-test because you are telling us that you are sure, which is not true. So immediately you miss out the at least one part, your statement becomes wrong. So please capture that one. So there's no way that we can say there is a relationship between y and the two independent variables. That statement is wrong. It's only applicable when you have only one independent variable. But when you have more than one, that statement is not applicable. So don't confuse with what you did with Mr. Chabalala. What we did with Mr. Chabalala, the alternative will be there is a linear relationship between y and the dependent variable, between y and the independent variable, because you have only one independent variable. But immediately you have two, the statement will change. You can also check this information from the guide. So now, included from the ANOVA table, we move to the t-test. How do we move to the t-test? Let's maintain what? Let's maintain the matrix approach. So now I'm going to share the notes on how to wait. Let me check it. Let me do this. Sorry for that. I want to share a Word one, not a. I want to share the Word document, not the PDF one. So now, I assume you understand why we move to the t-test. You don't just do the t-test because the question is saying do the t-test. You must know the main reason why are we doing the t-test. Oh, here's the notes. The slide is coming. Can you see something? Thank you very much. So now we're done with what? Now we're done with the ANOVA part, and we concluded that there is a linear relationship between y and at least one of the two independent variables. Now we have to move to the t-test. But before we move to the t-test, we must first come up with the variance covariance matrix. This information is there from a study guide. Those who have the study guide, let me check the page number. Study guide SSTB. This information that I'm about to discuss now is there on your study guide. Study guide. Oh, here it is. Let me tell you the page number. Anyone who's managed to get a page, please notify me that. Sorry. What is the page number?
It's 31.
I hope you heard it, guys. He's saying it's page 31. Let me go there. Yes, correct. It's page 31. That is the variance covariance matrix. Page 31. So whatever I'll be explaining is based on that matrix on page 31. When I talk about the diagonal lines and all those things, I'll be talking about the information on page 31. So those who are having the study guide, please go to page 31. Remember, we agreed that all our matrices that we'll be dealing with, they will be having symmetric matrix. We'll have a symmetric matrix. So even the covariance, variance covariance matrix is also symmetric. And I'm going to explain that table, that matrix there, how it works. I prepared some notes for you to understand what is happening on that matrix. The first one is that when you check that matrix on page 31 from a study guide, it's this one. On your study guide, is that the diagonal lines, diagonal values, sorry, the diagonal values. You understand when what we mean when we say diagonal, isn't it? Leaders, diagonal values from top left to bottom right. So if you are having a table, let me just draw a table here. What do you mean by diagonal? We're referring to something like this. In a case where we're having a 3 by 3 matrix, let me insert something. Diagonal, for those who are not following, diagonal, we are referring to these values which will be those zeros that I wrote there, they represent diagonal values. When I say diagonal, I'm referring to something like that. Diagonal, those zeros, we're referring to them as diagonal values. The other values which are not on the diagonal line, we call them off diagonal values. It means it's the other values which are not on what? On the diagonal line. So, but my statement here, what I'm trying to emphasize is that the values on the diagonal line from that matrix on page 31 from a study guide, they represent the variances, the inverse of betas. So when you see the first value there, someone's mic is on. Do you want to say something? Someone's mic is on. Can I continue? Can I continue, please? So these values, when you relate to the matrix on page 31, I indicated that the values on the diagonal line represent the variances of betas, of the beta i's. The first value, remember I said from top left to bottom right. So the order will be like this. This first one here, if this is a value, it will be the variance of beta 0. The one which follows, it will be the variance of beta 1. The third one, it will be the variance of beta 2, and so forth. If you have 5 independent variables, it means you apply the same logic. So, but now, to find the standard errors of the coefficient, you just take what? Just take the square root of when you take out the square root of beta 0, you'll find the standard error of beta 0. If we take the square root of variance of beta 1, you'll find the Omu. Oh, okay. Oh, no, it's fine. Let me finish this statement and then you'll go at 45. You go to bracket 45. Thank you for that, Omu. And then let me finish this statement. When you want to find the variance of beta 2, no, the standard error of beta 2, you just find that, check the square root of beta 2. So how do you find this matrix, variance, covariance matrix? It's the easiest thing to do. For you to find that matrix, you just multiply your inverse. You go to your inverse matrix, you multiply everything with the MSE. For you to find this matrix that I'm talking about, you only need the inverse. You already have the inverse from yesterday. You multiply that inverse with the MSE. I told you that you must know how to multiply what? Matrices, how to multiply a matrix with a single value. So if your MSE, like in our case, your MSE you said is 6.56. So you just go to that inverse, you multiply each and every value there by 6.56. By doing that, you'll be having a variance covariance matrix. That variance covariance matrix, we need it to do what? To go to the t-test. For us to perform the t-test, we need that variance covariance matrix. So during break, those who want to be busy, you can start doing what? Start multiplying those values. Go just take the MSE from the ANOVA table.
Go just take the MSE from the ANOVA table.
Multiply with the inverse. Sorry.
With the inverse. Sorry.
Let's break. We'll come back at 3:45. 3:50. Sorry.
3:50. Sorry.
Sir.
Thank you.
Yes.
Yes.
Sir.
I'm listening.
Sir.
I'm listening.
Yes, can you please go back? I didn't hear you. Your voice wasn't coming out. I think I have a problem from number 1. I didn't see.
I will repeat when we come.
I will repeat when we come back from break.
Okay.
It's break time until 10 to 4.
Let's proceed, sir.
Okay, Mrs. Manga, are you done with that matrix? I asked you to go and do the matrix. Are you done with the matrix? Can you hear me, guys? So from you, I don't need all the values. I'll tell you what I need. I need you to give me the diagonal values and tell me what do they represent. Tell me the diagonal values and tell me what they represent. So I hope you are ready. I'm just typing something here, but I'm done. So don't be surprised in most cases when I reference that you did these things with Mr. Chabalala. It's another way to prove it to you that whatever you did with Mr. Chabala is very, very important. We need that information now. So if you're just memorizing that side, you will have a problem. Because I will need most of the things that we have done with Mr. Chabalala. So can I get different members, please? Smanga, I'm fine. He said something. Omu, you said something. Maganama, Omu, and Christopher. Now, can you please give the other guys to share whatever they have? Maganama, can you please give me the diagonal values from your variance covariance matrix? Can you please give me your diagonal values? Maganama. Maganama. Anyone except Christopher, Omu, and Smanga? Can I get a different voice, please? Guys, are you there? Yes, Candy.
I have the first value is 7.48, if I'm not
The
mistaken.
first value is what?
7.48.
Is var of what? Of B0, isn't it? You're saying it's what?
7.48.
7.48. The second one?
8.300.
B1 at. I hope you understand that you are giving me the variances. I get Candy. That was 8 point.
Wait.
8 point what?
8.300.
8.300. The variance of B2.
0.0645.
0.0645.
05.
05.
45.
Oh, okay, sorry.
4.
Yes, I'm removing this one. 45. Thank you, Candy. Can I get another person to give me the standard errors of these variances? Not Candy, please. Can a different person give me the standard errors? Thank you, Candy. Can mute your mic. Thank you. Can a different person give me the values? Christopher, I said you must relax. Can a different person give me the values? But for that one, I can copy it, it's fine, because it's already here. The standard error of beta 1, beta 0, I'm told is 0.259313. S of B1, can you please give me the values, guys? Yes, Matilda.
Say, how did they calculate those values?
Which values, Dlamini?
The one near SSB, the standard error of beta 0.
Christopher, the lady is asking, can you please respond?
Okay. I used that formula of the, first of all, I found the standard error of the whole model. And then that
Yes. Can I show you a certain definition, Christopher? I will come back here. Let me show you something
I don't get
now.
you.
It's coming. Let me share something with Christopher before we can continue. Christopher?
Say, I did get the formula. I did get the formula that it's the MSE multiplied by the inverse of x prime x. It's just that I'm not getting the same values as the one they are getting.
No, I'm coming. I want to show you something. I want to show you guys something. Seems like we're not on the same page here. Why this thing is doing this? Please tell me if you see something from your side. Ne? I'm trying to share some notes here. I think. Share screen. Let me go back to my explanation before break. Tell me if you see something from your side. Matilda?
Yes,
Are you there?
I see something.
What I said, can you
yes,
hear me?
I'm here.
Yes, I said that whenever
Yes.
you want to find the variances, you will multiply your inverse with MSE. That's what you did, isn't it? And then I said, for you, let's check this statement, guys. Let's check this statement, the one that is been read in few seconds. The red statement. How do we find the standard errors? How will you find the standard errors?
Of the
Can you read
coefficient. The
Standard,
standard error
you
of
just
a
find what
coefficient is the square root of its variance.
is the square root of its variance. What is the variance of beta 0 in our case? What is the variance of beta 0, Matilda? Hey, Christopher, Matilda is experiencing network problem. Christoph. Christopher? Yes, it's fine. Omen Refile. Refile, you're saying is 7.48. That is the variance of beta 0. So, Refile, what would be the standard error then? Check this statement, the red statement. How will you find the standard error, Refile?
So we're gonna find the square root, which gives us 2.734958.
Thank you very much. Thank you very much, Refile. You just take the square root of what you are having. You don't have to go back to that formula that you used to apply with Mete Chavalala. That one is when you are not using matrix notation. When you use matrix notation, you just take the square root of that variance. You'll find there's not error. I know with Mr. Chavala, there's a formula that we are using, but now we're moving away from that. You just find the snot error from that matrix. Yes, Smanga?
I wanted to be surprised to say, how come the standard error was 0.02? I wanted to ask the same question, that isn't the standard area of a variance standard deviation of 8 beta 0?
Yes.
So now I'm
Yes. So I
answered.
know it's just a mistake. Maybe the time he was giving me the values, he wrote 2 by me, that 0 by mistake. You know, we cannot crucify him for trying. It's just a mistake. I hope Christopher saw his mistake. So we cannot crucify him for making that minor mistake. So let's go, guys. Let me get the other values. Matilda, are you back? Christopher, did you see your mistake? The mistake?
Yes, sir.
Thank you very much. So what is the correct one, Chris?
I'm
Chris?
still calculating. I'm still
Okay, it's fine.
calculating.
Can someone help Chris? Refilo, you gave me the value. Now you said it's what?
Sir,
You
it
said
was
what is the
2.734958. I gotta say, you said you mustn't round off anything.
Thank you. The second one for beta 1 is what? I'm
It
told
was
it's 2.
okay. It's also 88097.
09 with those values. The third one.
I got 0.2539.
Wait. Let me write the thing first. S of B2. You're saying it's what, Refile?
I got 0.25.
0.2.
2539.
Yeah. 39.
68.
And
So
some value.
shouldn't we
It's
round
fine.
off? It's a long number. Okay.
No, it's fine. Just write it the way it is. So now we have this information, guys. We can move to the hypothesis. So let's understand the reason why we have to do the t-test. I prepared some notes here, but whatever is in this is on the slide is related to what I said earlier when I was giving an example of possibilities that we expect when we apply the t-test. So you understand what we mean by the diagonal line. Now, and of diagonal values, those are the covariances between the two coefficient estimates, written as cov of B1, B2. The information, or BI, BJ. The information is there on the study guide. But the ones that we'll be using in most cases is the values on the diagonal line. The other one, the third one that I highlighted in red, this one is another part that can be covered if we have enough time. If you can check from the heading, it's also in red. If we have enough time, we can also go back to the correlation matrix of the betas. But it's not something that is a must to cover. But if we still be having enough time, we can go and explain what is happening there. So I explained this part here. You managed to do this during the break, variance of betas. You multiplied your MSE with the inverse. Now, we want to move toward testing the contribution of independent predictor variables. With this one, we will use, based on our module content, we will use two methods. The first one is the t-test, and the second one is the partial f-test. This test will lead to the same conclusion. So when you are writing the test, I might be specific that please test for the contribution of individual predictors using the partial f-test. Or I can say strictly use the t-test. Or I can simply say test for the contribution of the independent individual predictors. So with that one, it means you can use any of the methods, but sometimes it will be controlled by the given information. Seems like there's an end. Anyone? Is there a question? Oh, no, you are saying something? No?
Yes,
Sorry, I didn't see what you were writing under the chat, but I noticed that there's something. What is the problem now?
What?
so the answers I got, they are different from what the other colleague was saying.
Hello, yes, what did you get, Matilda? Sorry, is it Matilda? Matilda, what did you get? I don't know what's happening now. Can you hear me, guys? Okay, thank you, Omu. So I said when testing for the contribution of individual independent variables, we'll be using the t-test or the partial f-test. So it's possible that I can be specific that use this method. You see? So now let's check. Can you please read this given paragraph there? Just read that given paragraph. I'm giving you 2 minutes. Guys, are you done reading the statement?
Yes.
What you were simply saying is that whenever you have concluded from the ANOVA table that there is a relationship exists between y and at least some of these independent variables, you cannot tell from that ANOVA table which ones. So the main reason we move to the t-test is to check which one is related to the independent variable. And again, what did I say about the one which is not related? What do we do with that variable? I think if you read this statement, the answer is even from the it's here from this statement. I think there's a part where I said you remove the what? Here it is. When we fail to reject the null above hypothesis above, we do not need that variable. Here I was just giving an example that suppose you are testing for x2, for beta 2, sorry. If you are testing for beta 2 and then you fail to reject what beta 2 is saying, what the null hypothesis is saying, it means that we do not need that variable in the model. You see? We do not need it, provided we do what? If we fail to reject, that beta 2 can be 0, we can remove that. Remember, you're not removing beta 2. You remove the variable beta x2 because it's the one which is attached to what? It's the one which is attached to beta 2. But you still have to go and test for what? Because you are in this case, it means you'll be having 3 independent variables. You still have to go and test x1 and x2 separately. At the end of the day, now you'll give us what? The final model. So let's do the same with this, our given problem. Now we apply the t-test. We have to apply the t-test now. So I'll move to the whiteboard. We apply those steps for the hypothesis steps. So you know what you need now. You need the model that we calculated yesterday. You'll need the model that we calculated yesterday. So let me share them. Sorry, I'm not supposed to come in. So you need this information, guys. This value, because we're only going to test the betas which are attached to what? To x, to the independent variables. Because we want to check which independent variable is significant in predicting y. If it's only size, or if it's only age, or if the two that are important. So now you will need this one, this standard error. Again, you will need this other standard error. You will need these two values. So now let's move to the t-test. So now what we have to be specific. Testing for x1. H0, H1. Let's go. Now your focus is on what? Your focus is on y and x1. Only, please. Your focus is only on x, y, and x1. What would be a null hypothesis? Let's go. What would be a null hypothesis? Yes, in weights. You don't want mathematical that expression are mathematical. No, I need you to give me the statement in weights. The null.
Sir.
Yes, who's talking? Just click that button of so that I can notify, I can recognize you. Thank you. A0.
I'm just saying, what if you said there is no linear relationship between price and X1 it was size, I think.
Thank you. What would be the opposing statement?
There is no relationship. There is a relationship between
What type of
price.
relationship Whom are you talking about?
There is a linear relationship between price
And the
and size.
size.
Yeah.
Thank you. You see now, because our focus is only on one independent variable, we cannot bring in the at least part because now our focus is on y and x1. So the alternative will say there is a linear relationship between y and x1. Why specific here? Y and x1, or between y price and size. So now our alpha, let's stick to 5% because we used 5% to reject that or when dealing with the ANOVA table. So we cannot change the level when we get here. And then the t now, t is given by b. In case this can now we're dealing with what? Minus divide by s of b1. You remember the s of b1? Remember this part, guys? The standard error, if one writes standard error. So this part here, you know, is 0 because of what? We said beta 1 is equal to what? Equal to 0. So you know that this part will disappear. You will be left with what? B1 hat divided by the standard error of B1. So what is the answer? You have this information from what? Yesterday. What is the answer? The t calculated for when testing for beta 1. Beta 1, you have it from yesterday, and the standard error of beta 1, you just calculated now. And we move, please. Yes, Omo?
But for B1, I've rounded it off. Ne?
Yeah, if you rounded it off at this stage, it's a problem. Write the value the way it is. Write the value the way it is. 12.83 something, write those values.
The answer will be 4.454 something something something.
You're saying it's
4.4549 something something something.
Can someone confirm the value, please? Can you please confirm this value? Chris?
Yes, and I got different values.
Wow, how did you get it, Christoph? What is your beta 1?
It's 12,83445.
What is your SB1?
It's 0,699.
Christoph, 0. And how did you do it, Chris? I could we agreed, Chris, that what is your variance of beta 1? What is the variance of beta 1, Chris?
It's 0,48883.
No. Variance from that matrix. You got 0, something.
Yes.
Christoph. Guys, what is the variance of beta 1? Help, Chris. The variance. Candy and Refilo are the one who gave me the values. They're saying 8,300, Chris. Do you want an explanation? Even Lazarus Chidungwa is saying 8.3. Can I get the members now? It's fine. What's the first one? Damini.
Sir,
How did you get the 0.699? Yes.
I say
I'm listening.
the MSE, which is 6.564 multiplied by 0.0744 of that
Now we're
answer.
talking about the variance, isn't it?
Yes, I took the square root.
Yes. So you're saying
Oh,
first,
the answer for T.
no. I mean, I want the variance of B1. Let's start from here because I think the problem is here. Variance of B1.
The value 0.4889075541.
Can I get the MSE? What is your MSE? Your MSE is what?
6.564.
6.564. Is it like this? What is the value from that matrix? What is the value from the matrix that you multiply the second value from the diagonal line? The second value from the diagonal line is what?
0.0744.
No. Who's saying? No, I think there's a problem here. Danisila, you are right. Guys, your MSE is what? What is your MSE? Is it 111 or SSE is the one which is 111? I suspect you guys there's a group which multiplied the that inverse by SSE, not MSE. So what is the second value from the diagonal line from your matrix from the
0.0744
is from the inverse, ne?
Yes.
0.0
744.
Yeah, I see it. You are right. Is this the one? So I think you are the one who's right.
83174.
Yeah, it's fine. What will you get when you multiply these two? What are you getting, Danisile?
0.4889.
0.48. Yes, fine. Thank you,
When I'm
Danisile.
at the square root.
When you take the square root, you are saying you will get 0.6 something. It's fine. I want to check. So, I want to check someone.
Yes.
Whom you gave me 8.3. How did you get this 8.3?
Seven, I followed that person who gave you those answers.
Christopher, do you notice what happened?
I also got 0.488, but I want to know where did she get 0.0744 from which
From the
matrix?
inverse.
Of x
Prime
prime
x. That inverse of x prime x. Okay, when immediately you see it to the power -1, it means that is the inverse, isn't it?
yeah.
I wanted
Okay,
to trace how did she get the 0.488. I
Yeah,
agree
got
with
the thing.
what she did here. is correct. But now I want to trace who said it's 8,3 and how did you get that 8,3? Who said
It's me.
8,3? Lazarus, who's Candy? Yes, Candy. How did you get 8,3?
So I made a mistake. I used the incorrect
Yes.
spell. I used the SSE instead of MSE. I see it
Thank
now.
you. Guys, did you hear what Candy said?
Mm.
So it means your variances, they are not correct if you use the MSSE instead of MSE. So please go and do the right thing there. So based on your answer, Candy, Matilda, is it Matilda? What will be our T?
6.11.
Is the final answer? Is it the final answer, Candy? Sorry, Matilda.
Sorry, sir, I misplaced the answer, but it's 6 point. No. So I
So
don't
take
know
your
where I
time.
wrote it. Let me calculate
No, take
again.
your time, Candy. They will help you, Matilda. They will help you. Anyone who can give us the correct T value. The variance of beta 1 is 0,48. So you will say your beta, the upper part is 12.83 with the values there, divide by the square root of var of B1. What is the answer? I'm told it's
18.3536.
Yeah, I'm told the
18.36.
correct answer here is 18.36. This is the correct answer. The T tabulated for the size is 18 point. This one is, there's a mistake here. This is supposed to be B1. Sometimes in the textbooks they will write B10. This first part will represent beta 1. The 0 here, it represents that this is from the null hypothesis. But even if you leave it as this B1, you're still correct. So 18.36, let's finalize this one, guys. 18.36. Can you please go to the table and you check for, go to the T table and check for T of the degrees of freedom of errors, which is 17, and 5% divided by 2, which is 0,025. Yes, Christopher?
Oh, sorry, it's a mistake.
No, it's fine. Give me the answer.
No,
You go
I
and check for
wasn't.
17 from the t-test. You check for 17 and 0,025.
Oh, say it's 2,11.
I'm told it's 2,11. So what is your decision? What is your decision? What is your decision, guys? Yes, Chris? Chris?
We say 95% confidence we reject the null hypothesis.
Yes. At how many percent?
95% confidence.
Now let's focus on the hypothesis. That one, I think it will fit well when we're dealing with the confidence intervals of betas.
Oh, we say 5%.
Yeah, at 5% level, isn't it? So you reject the null hypothesis. It's fine. I agree, because T calculated is greater than T tabulated. And then what is your conclusion? What is your conclusion? What is your conclusion, Christopher? Yes, Danisile? Danisile?
There is a linear relationship between the price and the size.
Thank you. Now we know that we need the price to predict what? We need the size to predict the price. But we are not sure about the remaining one, which is beta 2. So now let's test for beta 2. Now I just want to change this. Now we test for beta 2. I'm just changing now. Our focus now is on beta 2. Let's do the calculations for beta 2. So what is the answer? The tabulated value, it won't change, but these ones will change. Variance of, here you'll need variance of beta 2. So the error, Danisile, can you please give me the value from that inverse? The third value from the diagonal line?
0.000.
Everything is 0.
It's 3 zeros, 5, 7, 8.
Yeah, like this. 5, 7, 8.
5, 7, 8.
When you multiply it with the MSE, what
7,
are you getting?
9.
What are you getting when you multiply with the MSE? Now
I got a number to the power negative 3.
What is that number?
Beta 2.
Is what?
3.79. 3.79.
We are saying it is to the power something, the power 3. Danisile, you said the number is to the power something.
It's 3.79 times 10 to the power negative 3.
So it means it simply says 3 zeros before that number. Give me that number now. We are saying is what?
Yes.
Give me the number now.
3799.
3799. So the another way of writing that number, Matilda, is in this format. When you say to the power negative 3, it means simply says write 3 zeros. Start with write 3 zeros before you can write those digits, those other digits. So now let's replace it here. Variance of beta 2. So you write that value from the beta 1 is 0, I think it was 0.005 something from that question that we did yesterday. So what is your final answer there? You divide it by the variance of the square root of variance of beta 2. Can you please give me the final answer and test? Can someone help our sister here? Let's not abuse my sister here. Can I get the final answer, please?
It's negative 3.45.
Christopher, you want to try?
The final answer for what?
For T, when testing for beta 2.
Oh, I got negative 0.9168.
Can I get someone who's agreeing with this value? Saying you got negative 0.91. What are you getting, guys? And again, thank you, no. This one I made a mistake. The way I wrote it is wrong because we're dealing with what? We're dealing with two-sided problem. Sorry, equal to 0. It's not equal to 0. Which means the tabulated value, we're supposed to write it as plus or minus 2,110. We're supposed to write plus or minus. So we have negative 0,91 and we have 2,110. So what do you do now? Let's do this so that those who are still lost, they can understand what is happening. That thing is two-sided. We have negative 2.11 and positive 2.11. You reject if the value is in the shaded region. If it's in one of the shaded regions, remember we're talking about the two-sided problem here. So if you have a value is in the shaded regions, you reject. But if it's in between, yeah, this space, the part that's not shaded, you fail. You fail to reject H0. You fail to reject H0. You fail to reject H0. So we have T calculated, which is equal to 0.91, and it is negative. What is your decision based on the two that information? What will be a decision? Are you still there? We failed to reject the null hypothesis at 5% level. So you fail to reject that. You fail to reject that beta 2 can be what? Can be 0. What is this thing telling you now? What was our agreement? If we have a variable that is not helping us to predict the dependent variable, what was the agreement about that value? If we have a variable that we think that is not going to help us in predict, that we know we proved that it's not going to help us to predict the dependent variable. So what will be our final model? Now we have tested. I gave you 3 options. So which option from the 3 is correct? I gave you these options. Let me remind you. I said it's possible that there can be a relationship between y, x1, and x2. I said this is the first possibility. So this first one will only be correct if this we have rejected when testing for x1 and we have rejected when we're testing for x2. This will be correct. Or we have this option, x1, and this one now, x2. The second one, we have noticed that x2 is no longer there. We're saying that no, x2 is not important, so we can remove it. The third one, we're saying no, x1 is the one which is not important. So based on my these three options, Which option do you think is correct? Which option do you think is correct? Based on those options, which option is correct? Y and X1. So your final model, now you write them. Remember, you are having a model. You write the model without X2. So you write Y equal to 10 plus 12,83 size. So this is our final model after doing all these tests. So now you know that the only variable that you need to, which can help you to predict the price, is only the size. The age is there, but it's not giving us any important information. So I will share the notes, the ones which are on the Word document. I will share those notes that whenever you have time, you can go through the notes. If you don't understand, you will consult. So when we reopen after your recess, on Thursday, the first period will convert it to what? Will convert it to the tutorials. That's that first period. The afternoon one now will do what? We'll continue with this multiple linear regression. Yeah, you can consult the refueler, it's fine. Remember, you are the only one. We are not closing. It's only students who are closing. So employees, UL employees, they will be coming to work unless if it is a holiday, like Monday. There's no that you can find us. But if it's a normal day, feel free to send your questions. I thank you. Enjoy. Which questions, leadership? Which questions and answers? Which questions and answers, Matlo? Matloha? No, we don't have questions here. Remember, what we do, we check the theory and we generate the question. So we don't have questions which are ready that I think I'll be able to send you. If we have noticed them at all, I can give you the notes that we're busy discussing here, but I don't have questions which are prepared. So please, the only way for you to understand the notes is to go back to the recording and then relate it with the what? The Microsoft, notes which I will be sending you from Microsoft Word. I don't know, unless if you have another suggestion, leadership, Tumbezo. Tumbezo. Yeah, we will. Let's meet after next week.